Welcome to the next edition of Grid Forward Forum. I'm Bryce Yonker. Today with us we have three lovely guests, and we're going to be talking about grid flexibility. Darren Murtaugh is joining us, as well as Bill Burke and Jessica Matlock. I'll let the three of you guys introduce yourselves in a second, but welcome.
Thanks for having us.
Great to be here.
All right, so we're going to be jumping into flexibility, a topic we've covered a number of times. It came up in my planning meeting yesterday for our main event, such a critical issue for the grid. I'll start with you, Darren. Why don't you introduce yourself? What's led you to the role that you're currently in?
Yeah, I'm Darren Murtaugh with ICF. I lead our electric distribution strategy practice, having come from about 22 years in the industry, leading transmission planning, distribution planning, and grid modernization efforts. Been with ICF for about a year now, and just excited to take some of my experience and to parlay that into a broader set of industry participants, engaging with folks in interesting states like New York, California, everything in between. So happy to be here.
Thanks, Darren. Jessica, can you introduce yourself?
Sure. I am the CEO of a generation and transmission cooperative utility, which is named PNGC Power. And we are 25 co-ops located across 7 Northwest states. And currently we are focused on building flexible power supply beyond Bonneville, just due to the massive amounts of energy needed in the region. I've had former roles at the Bonneville Power Administration, other utilities in the Northwest, and ran a cooperative in Colorado. Also worked in Washington, D.C. For Department of Energy and a U.S. Senator. So have some national perspective, but back getting into local regional issues.
Thanks, Jessica. And finally, Bill, over to you. If you can introduce yourself.
Yeah, thanks a lot, Bryce. It's great to be here. I'm Bill Burke, the founder and CEO of Virtual Peaker. I started Virtual Peaker about 10 years ago with the vision of how do we make demand as dispatchable as a gas turbine generator. I'm a product-focused founder. Today, the product team still rolls up to me. And in addition to my leadership role at the company, the product team is important. We like to stay very close to our customers and make sure we're building the things that are going to solve their problems. I've been in the space since about 2006 when I was at Berkeley working on programmable communicating thermostats and control like that. So I've been in the industry a long time as well.
Thanks, everybody, for being on. We've got some great perspectives. I'm going to start with you, Darren. And I mean, maybe in 2 words, why flexibility? Why do we need to add flexibility in the grid? Why is it important? What's your perspectives on, why this is a key driver right now in the industry?
Well, you want me to get close to 2 words, I'm going to say it's because we have to. But let me unpack that for you. So one of the things that we've noticed, and if you look at some of the reports that have come out recently from EEI and from LBNL, we are seeing a trend of investment in the distribution system that has really picked up over the past 10 to 12 years, to the point now that industry-wide capital expenditures in the distribution system represent an average of roughly 44% of total CapEx in utility spending. It's significantly more than it ever was early in my career. And as somebody who comes from a distribution background, there's a part of me that smiles and thinks to myself, good, it's about time. This is an investment that needs to happen in distribution. But on the flip side of that, it's putting substantial pressure on rates and affordability. So the question is, how can we address the challenges in distribution, especially, along with all of the challenges of a more flexible energy portfolio? How are we going to address those in a cost-effective manner? And what we're seeing is more and more utilities and commissions are leaning into flexibility as a way to combat the challenges in a more affordable manner. So they are looking at flexibility not because they want to and because it's cool, which it is, but because they have to.
And Jessica, you guys are looking to build out all kinds of infrastructure. What role does flexibility play in the stack for you all? Are you guys prioritizing it as a type of a thing that you're looking to achieve?
Yeah, Bryce, I think, as you well know, the Pacific Northwest is facing pretty big capacity deficits. So we are looking towards what Bonneville and the region is going to be doing for this under the WRAP compliance. So that's Western Resource Adequacy Program. In particular, we are really looking to bring in about 500 megawatts in the next few years just to meet those requirements. But some of those issues that we have are transmission constraints. There's a lot of folks thinking that we can build, a lot of solar and wind on the eastern states and bring that back over to Washington and Oregon. And in reality, there's huge transmission bottlenecks. And so we're really looking for more localized areas where we can develop generation, or other ideas that we can think through, like the virtual peaker power plants that we're talking about, DERs, just really looking at any opportunity to kind of reduce that strain on the grid, but also building new generation to meet these huge capacity requirements in the region.
Bill, you wrap up this intro as to why it's so important that we have these capabilities on the system.
I think it's interesting to think about the transmission side and the distribution side. Utilities have traditionally been using virtual power plants and finding a lot of value out of the capacity benefits. And in order to go into the transmission and distribution sides of the grid, I think utilities are going to have to think a little bit differently, and virtual power plants are going to have to act a little bit differently. There's a lot of value streams that we can capture through virtual power plants and through DERs. But the virtual power plants are typically operated at the program level, and the program people are mainly focused on capacity, and distribution and transmission are generally operated by different people than the programs people are they're dealt with by operations teams or maybe power purchasing. And those people don't trust virtual power plants today. We've been asking why they don't trust them. We've been asking that question for about 10 years now. And it's really because virtual power plants don't provide the visibility and they don't provide the predictability that they're used to in traditional power plants. So we've been trying to build technology, and I think fairly successfully, that gives utilities the analogs to central generation. And we've developed this new technology called top-line demand control. We call it TDC for short. Everything's got to have an acronym, right? So TDC is our 3-letter acronym for it. And it's really about providing utilities really granular forecasts of what the available capacity is, allowing them to specify a target output, and then the technology works to coordinate all those devices to hit that target and give the operations people the analogs to generation effectively. It gives them the ability to see what's going to happen and then count on the virtual power plant. And we think that's the paradigm shift that's needed to really take DERs into the control room, into power purchasing, and help unlock those transmission and distribution use cases.
So if we kind of talked a little bit about the why, now I want to talk a little bit about the what. And I'll start with you, Jessica. You guys are looking to a number of basically solutions, technologies, generation, a diverse generation portfolio to get the supply that you're looking for. How does the flexibility piece of it play in? What are you guys deploying to get there? You mentioned the bottlenecks on transmission, but maybe you can go a little further.
Yeah, right now we're looking at a number of technologies. I mean, I think the number one, in order to meet these capacity shortfalls in the Northwest, is the natural gas. So we are looking to develop pretty large natural gas plants. They're dispatchable, fuel efficient, and provide critical ancillary services to support the region and actually firm up all the renewables we have. But we're also looking to build a solar plus storage plant. And that obviously gives us also flexible energy while supporting our carbon goals for Washington and Oregon. And then we're exploring geothermal. We're assessing that as a baseload renewable resource that also meets our capacity requirements. And then, of course, we're keeping an eye on enhanced small modular nuclear. So the first one that's really coming online for the region is up in Energy Northwest area in Washington. So we're watching that. We still think that's a little bit far away. Now, those are the kind of our base load generation resources that have flexibility and capacity, but we are looking towards, what can we do at a localized level at the co-op? So again, that's where DERs come into play. How can we work with each co-op to find how they can shave some of their peaks to create less of a strain on the region? And those aren't going to be big capacity fills for us, but everything is part of that puzzle just so that we get to the end game of being reliable and keeping the lights on for our members.
I know the portfolio solution's what makes it strong, but quick question without getting into sensitive issues, Jessica, on just cost and timing, right? That's what everybody's trying to balance is, SMRs are great, but they can take a long time and they're also really expensive. Any insights on, the things that you're able to connect quickly, the things that are meeting cost expectations or aren't? Any just immediate reactions?
Yeah, I mean, because a lot of the tax incentives dropped for renewables, those are not as cost effective compared to natural gas. And the reality of it is that wind and solar require thousands of acres of land to be developed and a lot of transmission distribution lines to be built. And right now, we're finding that people don't want these things in their backyards. And in fact, there was a 1,000-megawatt wind facility being developed in Idaho called Lava Ridge, and that one was ended because the developer said they were going to export all the energy outside of Idaho. So people want to see development of these resources and the resource staying in the Northwest. So the quickest, cheapest, right now, most economic way to get this energy is natural gas.
And Bill, I was going to ask you the question because I've long remembered you comparing virtual power, aggregated distributed resources to a dispatchable gas plant. And so, why that comparison and are we getting to a place where that's truly an alternative at the scale that matters for the system?
Well, that's a great question. Why the alternative? I think virtual power plants traditionally can be built much quicker than a natural gas power plant. We've seen them grow very quickly in certain of our deployments in particular, megawatts online within a year or less. So very rapid deployment, which is great. They can also be used for a lot of other distribution and transmission use cases. I don't think we're unlocking them totally today, but there's a lot of different use cases for them, and that time to value is critical. I think there's some things to figure out along the way. How do you pay for them? You don't get paid the same way as you do with traditional power plants, although maybe that's not as big an issue for Jessica, being that she's at a co-op. It's still a reality for a lot of utilities.
And I was actually the paying for it part of it, Darren, was what I was going to ask you a little bit about, because the value streams of these things, these virtual aggregated resources are so distributed, are so numerous, but how do you bring it together in a cohesive and rational fashion? I was going to ask you about how we value it and turn that into something real.
Yeah, I mean, the first thing I'd say is the most mature means of valuing in the most established way of valuing is at the bulk energy level. And Bill, you referenced already how have these demand response programs been built historically? They were all designed around avoided cost generation capacity. And particularly when you're talking about utilities that operate in competitive wholesale markets and you have an independent system operator, I feel like the price here is arrived at through an open market. An open market is going to find the right price. Where things get really challenging, I feel, is when we're not talking about the bulk energy level. We're talking about retail distribution services. And how do we value the contributions that DER and flexibility can contribute to the distribution system? That's, I would argue, not really an open market. That is working with a local distribution utility that needs to figure out, well, what is the value? What am I willing to pay to get these services? And within that, I'm going to tie back to another comment that Bill said is you need dependability of the resource. That's the biggest barrier in distribution. If you don't have a resource that a distribution planning engineer, let alone a distribution operator, can dependably count on time and again, then they're going to be hesitant about relying on that resource in their plan. If they don't rely on it in their plan, then the value is actually zero. And if the value is actually zero, then how does it make sense to compensate for that? We can continue to go on and on about the millions of complexities. Another one that I'll just touch on here is that there's a minimum threshold that needs to be achieved in order for that value to really materialize. And again, especially at the distribution level where you don't have a backstop. If something doesn't come to fruition in the way that you need it, there's very little alternative on the distribution system versus when you're talking about bulk energy markets, you have access to contingency reserves or other resources that can pitch in. Getting back to your question, I think the biggest challenge today is how do you value these for distribution services? And when you do, what are the rules for priority access and co-optimizing that value stack across different entities, distribution versus bulk energy? And what is the opportunity cost of even enabling some of those use cases?
I'm going to pivot us a little bit and kick this one to you first, Darren, because when it comes to flexibility, we're talking about merging worlds. We're talking about infrastructure managers, asset managers, utilities sending signals to customers who ultimately have to act or decide that they're going to do something. So this idea of the role of the user, of the various types, end users, industrial users, and like, is so critical. Darren, how do we bridge this divide? How do we align incentives? How do we get operators and end users to kind of want the same thing and act in a rational fashion towards a universal outcome that's beneficial for everybody?
When it comes to the end use customer, one, you need scale. You need scale. So how are you going to get the scale needed from the end use customer and have enough access to that resource that the operators on the utility side can count on it and see value in it? First of all, the customer's the priority. It is their resource, and utilities need to be looking at these individuals as their partners. This is a partnership, not one owning the other. So for a customer to be interested in bringing their resource to a program, the first thing is keep it simple. Overly complex programs, that's a deterrent to customer participation. You're going to want streamlined enrollment. And another thing that we've seen is opt-in versus an opt-out approach. And many utilities that I've worked with, a lot of times they get nervous about defaulting customers into a program and requiring them to opt out of the program if they don't want it. However, I've seen examples where the default has been customers are opted in to a program and very few opt out, and it's worked very well. And the reason it worked very well is because the utility takes a light touch approach. Considering and prioritizing customer comfort. So what does that look like? It means knowing your customers. It means knowing what their preferences are. It means being very cognizant of how your operation of the resource can show up as an impact to the customer. And when you take a light touch approach, what we've seen, even with the default everybody in program design, is customers tend to favor it favorably. What that does for you is it gives you access to a larger pool of resources that begins to add that level of dependability and assurance to the operator that the resources are going to be there in the quantities needed.
Bill, I'll send a similar question your way. What important role does the end user of energy or the customer of the utility, what role do they play in this flexibility landscape? And if you have some perspectives on different types of users, whether it's industrial or residential users, and how they're kind of joining the party, if you will, that'd be great to hear.
Yeah, so I'm maybe going to go a little bit astray and reference back to something that Darren said earlier. There's a lot of value in there beyond just what's captured by the market. And utilities are in a unique position to capture additional values. So they can look at the distribution system, the transmission system in different ways. They can look at cost deferrals. And ultimately, the reason customers participate, a fair number of them participate because they want to make the world greener or a better place or whatever. But a lot of the reason, especially with large assets like batteries and EVs, is because they get paid to do it. And that's really the interface, right? You need to take a light touch, not upset the customer too much, but ultimately you have to pay them some incentives in order to get them to engage, to get them to lend you their asset in order to take advantage of it. And I think hearkening back to this idea that utilities have a lot more value that they can get out of DERs in particular and flexibility in particular, it means that just the merchant VPP that operates at the market layer can't provide the same level of value that a utility can. Utility can look deeper and operationalize them in ways that they can increase incentive levels, use their brand and their position as the trusted energy advisor to get the customers to engage. And then the goal is to get them to, not opt out in an opt out scenario. So it's ultimately really about the money, frankly. And then it's about not disrupting their lives too much. And that's, specific with residential. Most of what I'm talking about is residential, but it goes for C&I too. You can't disrupt production in a major way at a facility unless you're going to pay them a lot of money. And paying them a lot of money is contingent upon getting value and getting value at the utility level, and unlocking those different value streams are really important to that point.
Jessica, I'm going to ask this a different way to you. I mean, you can pivot it if you'd like, but what do your members, what's the co-ops that you guys are working with? I mean, obviously they're looking for reliable, affordable power supply from you all, but like, what do they want, and why would they be willing to jump through all the hoops to do some of these newer type solutions if it's something that maybe they haven't done before? There's a couple different questions there, but
Sure.
What's a priority for the co-ops?
Yeah, I mean, I think that one, we're working with, just to keep this in perspective, 25 co-ops in 7 states. Some of them only have hundreds of accounts. So when we talk about virtual power peakers or other ways to achieve power supply at economies of scale, you're talking about really small communities that don't have any money for this. So that's where these GNTs, again, like PNGC, we're aggregating our small co-ops needs into collective buying and planning purposes. So when we look at DER programs or energy efficiency or ways to help shape loads, it's really our co-ops are saying, okay, what's going to greatly benefit our users? And for example, I was just in Wells, Nevada yesterday with a really small town. Their number one happening in that area is cattle and ranching. And so when we talk about these new technologies, it's more, you need to talk from that vantage point of saying, how can a virtual power plant or some of these other options help the farmers and ranchers, right? And it's more of a factor of, hey, we're going to help you shape your peak so that maybe we do the irrigation at different times of the day so that we avoid these more expensive times of power. And that'll save you money. And that'll bring in these local generation plants locally, so you're not buying it more expensive out on the market. Now, one thing to keep in mind in the Northwest, though, is that Bonneville Power does not have any price signals that create this opportunity. There's nothing like in the tri-state area where I was before, where there was a great incentive to reduce your peak demand using DERs, even putting virtual power peakers at the end of the line because you have voltage issues. That was a real key aspect of VPPs, but really you have to work with whoever the marketer is in the first place and the wholesale provider, which is Bonneville. So you go back to them and say, you guys really need to put in some incentives or other mechanisms where co-ops and small utilities, any size utility, can benefit from in order to put these systems in place.
Costly distribution upgrades, frequent extreme weather events, demand surging from an onslaught of distributed energy resources adoption. Do these challenges sound familiar? If so, you need Virtual Peaker's cloud-based distributed energy platform. We're empowering modern utilities with next-generation virtual power plant solutions to maximize the value of DERs. The Virtual Peaker platform unifies all aspects of DER management, from DERMS to customer engagement and demand forecasting. Learn more at virtual-peaker.com.
All right, well, we're going to head towards kind of our last area here, and I've got kind of different questions for you all to answer on it. So feel welcome to respond to the others. But Jessica, I'm going to start with you. And if there's one word to categorize our last chapter here, it's scale, because I think adding flexibility to the system only really matters if we get it to a scale that's meaningful. And so, getting to those higher levels is what I want to talk about here in our last part. And Jessica, I'll focus this first one to you in on the people side of the equation, right? If we're going to do this, we have to have capable teams. We have to have staff that are able to maybe learn some new skills, and at these smaller operators, that's always a concern, right? God bless all the co-ops across the country, but they wear so many hats, and something net new is always difficult to achieve. So how are some of these innovative solutions, whether it's demand side capabilities, new flexibility, or any innovative capabilities, how can we have the capacity at these co-ops to be able to bring those sorts of solutions in effectively?
Yeah, that's a great question. And that is one reason that PNGC doubled in size last year. So we went from 16 to 25 co-ops. And one of the reasons is because a lot of these co-ops realized that in order for them to modernize, to bring in these new technologies, to plan for the future, they didn't have the staff. And they couldn't actually hire and attract staff to some of these really small areas. So they joined PNGC because we have the technical capability and the staff to provide that. So we are an extension of these co-op staffs, and that is the benefit. And again, because we can aggregate, now we can develop these programs where we will create the DER program, we will create the energy efficiency program, and then we will roll these out to our very small co-ops and support them. So we're trying to remove that barrier, right? Where again, a lot of these co-ops don't have the technical capability. They don't have the funds to hire. So they come to us, and then we provide that option. So it really takes away a lot of the risks, the unknowns. It creates more technical capability. It brings more progress to these regions. So the G&T model where we're able to aggregate and bring in all these small co-ops is very useful for us and for our members.
Very cool evolution of the G&T provided services. Thanks for sharing. Darren, I'm going to take the data side of the question to you, right? Data can, in theory, unlock so much potential, but how are the analytical capabilities allowing us to bring these sort of solutions to scale faster, more effectively? I could ask a lot of questions on that, but I'll kick you a broad one, see where you may take it.
Yeah, you may have picked up already that a lot of my conversation steers us toward distribution, and we've had as a cohort here, we've had a lot of good discussion about the various domains where flexibility shows up. It shows up in your energy resource portfolio. It shows up in transmission. It shows up in distribution. But with a lot of focus now being shifted toward addressing localized challenges, whether it's overloaded system elements or even flexible connection, being able to bring on new load faster through a better use of flexibility, it really starts begging the question about architecture. To what degree does it make sense to continue to have the logic behind all of this be in a centralized control versus a distributed control? And within that conversation, how are you using advanced analytics to not only make sure that you're not impacting customers, but that you are creating the dependability, the assurances needed so that it becomes a resource that distribution operators are willing to rely on. And what I'll call out is one of the products that ICF has, we call it DER Insight, which leverages building-specific models. And it's also informed through AMI data so that you get what essentially looks like a digital twin of your system. And you overlay some machine learning on top of that to identify and group like customers together, thereby enabling more predictable performance. And we are using that in the day ahead markets in PJM and elsewhere, where we are seeing the load shapes, we're understanding the load shapes, and we're dependably able to say how dispatch of these resources are going to help to shape those load shapes and be successful in that day ahead market in a dependable fashion.
And Bill, I love Jessica's example of a model, but I'm going to kick this question to you on the business models, on the pathways that allow scale of these solutions to come wider because the incentives are aligned and the structures are well set. So how do we, what are some of your thoughts on this area?
That's a rather broad topic, but I'll see what I can do. I think that getting scale in virtual power plants, in my belief, is dependent upon the utilities' active participation in the virtual power plant, using their brand, using their resources internally to provide the credibility to this participation. It's also important, like I said previously, to get the incentives up to a level that customers can really participate. We see a lot of success when utilities think differently about DERs and start thinking about distribution system in particular and valuing cost deferment. We've got a great customer, Hydro One, who started specifically thinking about capacity with thermostats, and they pretty soon after expanded into batteries and EVs and all the other line voltage thermostats and all the other types of devices. But then they continued to evolve their virtual power plant to then target the distribution system, and now they're using it to deal with congestion in their distribution system, which I think is not particularly common in utilities today. But again, unlocking additional value streams allows you to drive higher incentives, which will allow you to scale more quickly because you can get customers interested more quickly.
All right, last question, and it's a bit of an X factor, so take it wherever you would like. Whoever's ready can go. What is the favorite thing that you are working on right now and or learning about? I'll just be curious to know because I think it's going to be a little bit different from each of you. So is anybody ready to jump in on something that they're fascinated and really excited about what they're working on right now or just learning about right now?
Maybe I'll start. I'm really excited about what we call DER orchestration and operational potential. And if you talk to any program operator anywhere, they will tell you, yes, I may have 100 megawatts of resource. That doesn't necessarily mean that each time I call on it, I'm going to get 100 megawatts. I may get 80 megawatts. I may get 20 megawatts. It depends. There are many variables that come into play. But what we do believe, our hypothesis, is that no singular resource type is likely to have all of the attributes and characteristics that you're going to want or even need to see in order to deliver dependable distribution performance. However, an orchestrated design across disparate DER types, disparate flexible resources, each of them showing up in the right capacity at the right time to solve the right problem, can deliver dependable performance. And when we say DER orchestration and operational potential, what we mean by that is we're going one step further than your technical achievable potential. Technical achievable potential being, hey, here are all the resources that can show up in the region. But what subset of that can I count on to deliver a specific defined distribution use case with clear performance expectations? Putting a number to that and then substantiating it with some statistics, I think, is what's going to be needed to unlock that, to break that key barrier to enabling these resources to participate effectively in distribution markets.
Great. Jessica or Bill, anything to mind?
Yeah, I mean, I guess I'll go next. I would say, Darren, to your point, that's pretty exciting. I would like to work on that. One thing that I'm more involved in right now is kind of the bigger issue of the Northwest and how to not have a blackout. So I think everybody remembers the storms back in January 2024. I don't think people realize how close we were to actually a blackout. It was within hours. And most of our energy generation coming into the region to help us not have a blackout was outside of the Northwest. So to Darren and Bill's points about we should really be looking at the distribution system, that excites me, and how that marries up with the bigger picture of we really have to focus on building large capacity projects in the Northwest for reliability. So we got to bring that in. How do we do that? And then how do we, again, reduce some of the stress at the distribution level with these virtual power peakers, with these DERs, because it can't be one solution, right? It has to be multiple solutions. So to me, that's the most exciting thing is figuring out how all these things fit. And on top of that, how do we meet these future RAP capacity requirements? Because there's going to be $1 million of fines coming our way if we don't meet these. And then on top of that whole layer is people are going to EDAM and SPP Markets Plus. So then how is these two markets going to also interact? Because how we move power in the Northwest and even among utilities and wholesalers, that's going to change the landscape. So what does that look like? That's pretty exciting to me.
All right. Last word, Bill.
Well, I'm pretty nervous and excited about transitioning virtual power plants from the programs teams into the ops teams and the power purchasing teams. I think this is a massive paradigm shift, and with that comes massive challenges. We believe, we know after talking to customers that top-line demand control is the technology that can help make this transition. But change management at any organization is challenging, especially at a utility. And these people have been keeping the lights on literally for over 100 years, and changing the way they operate the grid, operate the distribution system it's challenging. It's hard. It's hard to put these things into place. And I'm excited and quite nervous about the change all at the same time.
Your guys' favorite things are all daunting, but they're important.
If I can offer a thought / comment on that.
Yeah.
You're right. Change is hard, particularly at a utility. A reason for that, I feel, is because change represents uncertainty. Uncertainty
Yep.
can be a threat to reliability, and reliability is something that utilities have to be excellent at. How do you address that uncertainty without impacting reliability? That's where flexibility comes into play. Flexibility done right can be a tool to combat that uncertainty. Flexibility done poorly will have a detrimental impact on reliability. And that's that pinch point. That's what we need to, as an industry, get really good at, is leaning into flexibility as a tool to combat uncertainty.
Yeah, I couldn't agree with you more on that respect, Darren. I think I wrote down, if they can't count on it, the value is zero. I think you said that a few minutes ago. If they can't count on it, the value is zero. So giving them the tools that they can count on it, believe in it, predict it, and then control it is crucial across the board.
Jessica, Bill, Darren, thanks for being on with us.
Yeah.
Wonderful
Thanks for
chatting.
the opportunity.
Thank you all.
Thanks again to our season sponsor, Virtual Peaker. If you enjoy Grid Forward Forum, please follow us on your favorite podcast platform, give us a like or a review, and tell your colleagues. You can listen to all episodes and learn more about our efforts to advance the grid at gridforward.org.